In this video, I'm going to show you how I conducted the independent sample t-test in SPSS relevant to the difference in perceived intelligence for faces wearing glasses versus not wearing glasses. So first, just a few comments about how the data are set up here. I've got the dependent variable intelligence in one column. So these rows represent cases, and I've got a total sample size of 80. And we can see that the first person's face got a rating of 2 out of 7 for intelligence. And we can see here that there's another variable called glasses, and it's coded zeros and ones. And 0, if you look in variable view, 0 is coded by me to equal no glasses, and 1 is yes. So we've got each person's face has a intelligence rating, and it also has a demarcation whether they're wearing glasses or not. The last thing I'll point out is that you can see these little symbols here, and I'll show you what these mean. You can see that it says measure in variable view, and I clicked ordinal because technically that dependent variable is measured on an ordinal scale. It's 7-point ordinal scale, and nominal is what the independent variable is measured on. Now I mentioned here just briefly, I'm going to cover assumptions later in the textbook. It actually is perfectly fine to conduct an independent sample t-test on data measured on a 7-point ordinal scale, even though, strictly speaking, it assumes interval ratio. I'm going to talk more about assumptions later in the chapter, though. I want to get to the main analysis. So go into Analyze, Compare Means, Independent Sample t-test. So put intelligence into the test variables box and glasses into the grouping variable. And you have to define the groups because you might actually have a variable with 3, 4, 5, 6, 7 different groups. You need to tell SPSS what group you want to compare. And I want to compare group 0 with group 1, which according to the number scheme is no glasses and yes glasses respectively. Now if you click on options, there's really not much here except for the confidence interval is going to be 95%, which is what you want. Click continue. And I'll cover Bootstrap in another video. So click OK. And here we have the actual analysis. You get the descriptive statistics first in the group statistics table. We can see that the sample size is 40 for each group. N is a symbol for sample size. And then we've got the means here. So not wearing glasses, the faces received an intelligence rating of 4.03 out of 7. But once those same faces had glasses on them, and a different group of people rated those faces for intelligence, we got a mean rating of 4.43, which obviously is numerically different, but we don't know if it's statistically different. And the standard deviations are here, 0.768, 0.813, and the standard error of the mean for each group. Now, I'm going to cover assumptions again more later, but I'm just going to quickly state that the assumption of homogeneity of variance has been satisfied. More importantly, for now, is that the t-value is negative 2.263, equal variance is assumed, with 78 degrees of freedom, and the p-value is 0.026, which is less than 0.05. And because this p-value is less than 0.05, I rejected the null hypothesis of no difference between these two means. I'm sufficiently confident to declare a statistically significant effect that these two means are from two different populations. And by that I mean two different populations of perceived intelligence. So with a certain level of confidence that's less than 0.05 in terms of making a fool of myself, I'm confident of stating that there probably is a difference wearing glasses versus not when it comes to perception of intelligence. Now SPSS reports simply the mean difference here, so it's literally 4.03 minus 4.43 equals negative 0.40. And this is the standard error associated with that difference. So the standard error of the difference, the denominator portion of the t-test formula, 0.177, and if I calculate the ratio, negative 0.400 divided by 0.177, I get the t-value within decimal places, negative 0.263, negative 2.59, basically the same thing. Mean difference divided by the standard error of the difference. Now finally, we get the 95% confidence intervals for the mean difference. And we can see that the mean difference was associated with a lower bound 95% confidence interval of negative 0.75 and an upper bound of negative 0.048. And because both the lower bound and the upper bound are on the same side of 0, and in this case it's negative, we can declare a statistically significant effect. And that corresponds with the fact that the p-value here is less than 0.05. It's 0.026. Now what these confidence intervals mean is that if I ran this study many times over with a sample size of 40 in each group, I would expect to see 95% of the differences between the mean across all those large number of studies that I theoretically would conduct over and over again with different samples of 40 people in each group to range somewhere between negative 0.75 and negative 0.048. So that is the t-test in SPSS. Again, I'm going to cover assumptions later.